This lesson is about the data collection sheet for a structured data collection for control charts. And hello again to this lesson, which essentially has two learning objectives. At the end, you should know what a failure mode is and be able to name some examples. Furthermore, you should of course be able to create a simple data collection sheet. This lesson is divided into two chapters. In the first chapter, we look at some failure modes and their categorization. In the second chapter, we discuss the structure of two data collection sheets. Once for the number of defects per unit and once for the number of defective units. If you are not familiar with these terms, please check out the previous lesson first. However, before we come to the failure modes, here is a brief overview of the control charts that have just been mentioned for a better understanding. This picture shows the relationship between the various characteristics and the control charts used. The different characteristics are shown on the left and the different control charts on the right. The quantitative characteristics shown on the left can be divided into two different categories. First, the variable characteristics. These are all characteristics that can be measured. They always have a value and a unit. Examples of this would be the length, hardness, weight, surface roughness, or tensile strength of a component. Second, there are the attributive characteristics. Those are all characteristics one can only count. On the right side, we have the different control charts for attributive characteristics with a yellow background. The data collection sheet is used, among other things, for data acquisition for these control charts. The control charts themselves are explained in separate lessons. Let's start with the preparation for the creation of a data collection chart. The failure catalog. When we talk about failure modes, or failures for short, for now we are not looking at their causes or their consequences. However, here are two ways to identify potential failures. The so-called cause-effect diagram is used to identify the cause of an error. I just want to show that potential failures can have various causes. For example, a person can make a mistake. A machine can be defective or incorrectly adjusted. Changing environmental influences can have a negative effect. The material used can be unsuitable or does not meet the specifications. Or the method is not the right one. All these causes should be included in your considerations to identify potential failures. Another option is the failure mode and effects analysis, abbreviated FMEA. With it, possible failures are evaluated according to their severity, their probability of occurrence, and their probability of detection, each with a rating figure. Various failures can be compiled in a failure or error catalog. For example, this can be extracted from an FMEA. The various failures are listed and categorized in a failure catalog. Examples of different types of defects would be, for example, scratches on a bonnet, paint inclusions on the bonnet, or paint bubbles on the same. For example, these three errors could be grouped under the category bonnet errors. Other types of errors in other categories would be missing soundproofing, or a missing spring, or a component may be too large or too small in diameter, or a lamp may simply does not work. All these errors are examples of attributive characteristics. This means that a requirement is either met or not met. There is no in between. This is an example from a previous lesson to illustrate potential failures. On the left are a bunch of screws with a blue coating. One screw is uncoated. This is an example of a number of defective units. It's one defective unit, let's say in 1000 coated screws. On the right side, however, we have an example of a number of errors per unit. In this case, the unit is a single part made of die-cast zinc. This item may have multiple defects. Here is an example of shrink holes and a missing tooth. So, now that we have gotten an overview of the failures and why we make the distinction between defective units and defects per unit, in this chapter, let us take a look at the structure of two data collection sheets as an example. Let's start with the data collection sheet for the number of defective units. For the purpose of simplicity, we will ignore the complete structure of a form with a header, which contains information about the product or the characteristics, place of use, and so on. An information on the release status of the data collection sheet should also be visible on it. But all that would lead too far, and we limit ourselves to the core content. The left column of the data collection sheet lists the various failures that can occur. Either the number or the proportion of defects found can be entered in the middle part. If, for example, in a batch of 1000 screws, 5 screws were found that were missing the coating, then the number would be 5 and the percentage would be 0.5%. The sampling frequency and the sample size should be specified by a production control plan. Depending on whether an X, NP or P chart is used, either the number of defective units or their proportion is required. In any case, any change in one of the 6M should also be noted. So, changes in the influence of man, machine, material, environment, the method or the measuring system. This history or log is an indispensable aid when analyzing the causes of errors and for process improvement. A part of an NP chart is shown below as an example. If the number of defective parts in one of the random samples was more than 11, this would be an indication that the monitored process is no longer under control. Among other things, with the help of the records, the cause would have to be found and the process readjusted. The data collection sheet for the number of errors per unit has the same structure as that for the number of defective units. A considered unit can, for example, be a single part, such as a complex injection molded part, or 1 meter of a 10 meter long weld seam. For example, within a meter of a weld, the following defects could occur: root fusion defects, flank fusion defects, or pores and the like. All these defects would be counted and totaled for a meter of weld. In this case, the sum of all errors in the sample would then be entered in the C chart shown below. Here too, exceeding the control limit would indicate that the monitored process is no longer under control. Then the cause would have to be found and the process readjusted. Of great help would again be the records of changes in one of the 6M. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the two most important key messages. Before creating a data collection sheet, identify potential failure modes that could occur. Create a failure catalog with clear acceptance and rejection criteria. A data collection sheet is not only used for data collection, but is also an excellent tool for analyzing the root cause of problems and for process improvement. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care and see you next time. Bye!